Hi. Today we are going to be talking about solving inequalities. Now this is very similar to solving equations, except we're going to have an inequality instead of an equal sign there. Still going to be adding opposites, still going to be multiplying and dividing, still going to be combining like terms, still adding opposites if possible, and clearing fractions. Remember all those things that we did before, we're still going to do here. There is going to be one trick when we start solving these, so please pay attention to that. To start with, a little refresher. We have 4 different inequalities. So the first one, this is less than. This one is greater than. This one here with a line under it. This is less than or equal to. And the last one is greater than or equal to. So the only difference between these two is there's one more answer to that. And we'll get to that when we get to graphing. But pretty much if something's less than, it's got to be less than that number. If it's less than or equal to, it actually equals that number and is less than. Now a couple other words that go with it is if it's less than or equal to, could also think about no more than. You can add that into your notes. And again, the notes are included. Please look at the notes first to kind of copy this down as a template, and then you can kind of fill it in as we go. Also, if you're taking your own notes, make sure you put the title up here, 1-5 Solving Inequalities, and today's date. Remember, you want to keep things organized. Greater than or equal to could also be at least. So places where you'll see this, greater than or equal to. You have to be at least 16 years old to drive legally in the United States. You have to at least be 21 years old to drink legally in the United States. You need to be at least 59 and a half to collect on your annuities without a penalty. And that's something you don't have to worry about for a while. But you want to think about those words and how it works. If we're looking at these problems and we want to write these down, a number x is greater than 15. We're now on number 1 on your page. So number 1 would be x greater than 15. We would write it like that. This number is greater than that one. Number 2, a person must be at least 35 years old to be president. So you want to think which one is it? And it's at least. It is this one. So you can put x greater than or equal to 35 years old. Number 3, a light bulb can be no more than 75 watts to be used. No more than. Here's less than or equal to. Less than or equal to 75. And then finally, it says Ashley earns more than $35,000 a year. Now it says more than. This does not include $35,000. It's saying she's making more than $35,000. So it would be this symbol here. There's a big difference between a greater than and a greater than or equal to symbol. Make sure we understand the difference. So we jump up to part 2 where it says graphing. So it says, first of all, open circle versus closed circle. Now, it will be an open circle if it is a greater than sign or a less than sign. And I'll explain what open circles and closed circles are here in a minute. If it's closed, this means greater than or equal to, less than or equal to. Because when we're graphing, there's 2 things to remember. Whether it's an open circle or closed circle, and also which way does it shade. It shades to the left if it's less than or equal to. And we shade to the right if it's greater than or greater than equal to. So when we're graphing these, it's going to be on a number line, and we have to think, is it an open or closed circle? And then are we shading left or to the right? And then we will practice that as we go along solving these problems. All right? So when we go to solve the problems, we solve it just like an equation, but we keep the inequality, and then we also have to show the graph. The graph just shows a picture of what our solution is. There is one trick though, okay, and I noted it part B on your notes. If you multiply or divide by a negative number, you must flip the direction of the inequality. It's just something you have to do. And it's only if you multiply or divide by negative. If the answer is negative, we don't have to flip it. If we subtract a number, don't have to flip it. Only if we multiply or divide. So we're going to go through 3 examples. And again, remember, same possible steps are involved just like when we solve equations. So the first problem, we have 3x plus 8 is less than or equal to 20. Now again, very straightforward. We don't have any like terms. We have x is only one side. So I'm going to start by adding opposites. Now I did not multiply by negative, so keep this as a less than or equal to. Copy down to 3x. And we have 20 and negative 8 is 12. We now divide by 3. We divided by positive numbers, so we do not have to switch. And we have this x less than or equal to 4. Now when we're graphing this is a number line. We're doing it in one dimension. Again, number lines go on forever. You can start them wherever, you can stop them whenever. To understand, they go on forever. Now, less than or equal then to. That means 4 is a solution to our problem. So we represent with that with a closed circle, because it can't equal a 4. And since it's less than, we want numbers that are less than 4, which are 3, 2, 1, 0. So we shade our line and we go to the left. So every solution to the left of 4, including 4, is an answer. If we plug it in, it will be true up here. We look at number 2. 4 parentheses 3 minus 5x greater than negative 28. So I see I have parentheses. First thing, I want to distribute. 4 times 3 is 12. 4 times negative 5x is negative 20x greater than negative 28. Still didn't multiply by, or divide by anything. I just distributed. So I don't have to change the direction. The opposite of 12 is negative 12. Right? I'm adding or subtracting. I do not change the sign. This cancels out. I'm left with negative 20x less than negative 40. Now I divide by negative 20. I divided by a negative. Therefore, I need to flip the inequality. Negative 40 divided by negative 20 is a positive 2. So my answer will be x less than 2. On a number line, I'm going to start with 2 there. Because it's only less than, it becomes an open circle. 2 is not a solution for this problem. It starts there, but it is not a solution. And again, we have less than, and we shade to the left. So every answer to the left of 2, every number to the left of 2 is a solution. Okay. Now we get to our last problem, number 3. Now this has a couple little twists to it. 12 greater than or equal to 7 over 2x minus 9. Now if you want to multiply by 2 because you want to get rid of your fraction, you can, but there's only one there. If you want to take that step, that's fine, or you can just solve it the regular way. So I can add 9 to this, to both sides. 12 plus 9 is 21. I do not need to change the direction of the inequality. It's greater than or equal to 7/2. Now, I want to get rid of that 7/2. Now remember in the notes we took a couple days ago, it's either we divide or multiply by the reciprocal. The reciprocal of 7 over 2 is we have to flip the fraction. It is 2 over 7. And it's 2 over 7 here. Now again, 1, 2 on top, 1 on the bottom, that cancels. The 7's cancel. So I'm left with x. I multiply by a positive number, so the direction does not change. Now, when I multiply, I know that 7 goes into 21. 7 goes into 7 one time. 7 goes into 21 3 times. I now have 2 times 3. I have 6. Now, if that's hard to see, if you just want to go 2 divided by 7 times 21 in your calculator, that will work also. But I end up with this, 6 greater than or equal to x. Now, there is one problem that might cause you confusion. The x is on the wrong side. So we want to flip-flop it. I know some of your teachers a couple years ago said flip-flop. So put the x first, put the 6 next, and we flip-flop the inequality. So instead of shading to the right, which you originally might want to do, we actually have to shade to the left again. So again, at 6, we use a closed circle, and we shade to the left. Now I'll talk more about this in class. But the reason why you have to flip-flop it is because the variable is on the wrong side. Okay? Hopefully this helps. Make sure you turn your notes in, and we'll talk about more of this next time.